start today's session by asking you to just check in with yourself for a second right now. Where's your phone? Is it in your pocket? Maybe it's in your hand right now. Are you, half listening to this while scrolling through a feed of 15-second videos?
It's a fair question.
And if you are, look, don't worry. We are not here to judge at all. In fact, we're kind of here to validate that exact impulse.
Right.
Because today we are tackling a topic that has, fundamentally rewired how we kill time, how we entertain ourselves, and as this huge stack of research on my desk suggests, how our brains actually physically structure themselves.
Yeah.
We are talking about the short-form video phenomenon, TikTok, Reels, Shorts, the endless scroll.
It really is the defining media shift of the decade. We've seen formats change before, right? From radio to TV, from TV to the internet.
Sure.
But the velocity of this shift.
Yeah.
It's completely unprecedented. And I think for a lot of people, the conversation just kind of stops at kids these days, or I waste too much time on my phone.
Right. It feels like a personal failing or just a generational quirk.
Exactly. But the papers we're diving into today, and these range from early observations in 2019 to some really heavy-duty neuroimaging studies published in early 2025, they suggest we're dealing with something much more significant than a bad habit.
The phrase that I keep seeing pop up just in the cultural zeitgeist is brain rot. You see it everywhere.
All over the comments section.
All over the comments. Someone will post some bizarre, chaotic 15-second clip, and the top comment is just, "My brain rot is terminal."
Yeah.
And it's used as a joke, right? A bit of self-deprecating humor about feeling foggy after maybe a 3-hour binge scroll.
We've all been there.
Oh, yeah. But when I was reading through these neuroanatomical studies you sent over, I realized that rot might be a bit hyperbolic.
It is, yeah.
But restructuring is scientifically 100% accurate. The brain is physically changing.
That is the headline. That's the pivot we need to make. We need to move from the colloquial idea of rotting, which, implies decay and destruction.
Right, like it's just dying.
Exactly. We need to move to the scientific concept of neuroadaptation. The brain is, at its core, an efficiency engine. It optimizes itself for whatever environment it inhabits.
So it's just learning.
It's learning. If you put a human brain in a forest for 10 years, it optimizes for tracking game, for navigating terrain, for identifying plants. If you put that same brain in an environment that is defined by a hyperspeed, algorithmically curated stream of 15-second dopamine hits,
It adapts to that.
it adapts to that. The problem, which I know we're going to get into, is that the adaptation that makes you really good at TikTok is often a maladaptation for the rest of reality.
Before we get into the fMRI scans and the gray matter volume, let's just establish the sheer scale of this environment, because this is not a niche subculture anymore.
Oh, not even close. It's the mainstream. As of, January 2024, TikTok alone had nearly 150 million monthly active users in the United States.
150 million, what is that, almost half the country?
It's nearly half the population.
Yeah.
And that's just one app.
Yeah.
And if you narrow in on the demographic breakdown, specifically Americans aged 18 to 29,
Yeah.
the usage rate just saturates.
Yeah.
It's somewhere between 62 and 85%, depending on which poll you trust. This is the dominant mode of information and entertainment consumption for arguably the most cognitively malleable generation.
And that's what makes this deep dive so urgent. We aren't talking about some fringe issue. We're talking about the primary input for millions and millions of developing brains.
Right.
So our mission today is to move past the headlines. I really want to know the mechanics. We're going to look at what the literature calls the neuroanatomical and functional substrates of SVA, short video addiction.
SVA, yeah.
We need to answer the big questions. Is our attention span actually shrinking, or is that a myth? Does the brain physically change shape? And, the question I ask myself every single night at about 11:30 p.m., why is it so physically hard to just put the phone down?
To answer that, we have to treat SVA as a distinct behavioral entity. This is really important. The research is very clear that this isn't just internet addiction or screen time.
So it's different from, say, being addicted to online chess or something.
Completely different. You could spend 10 hours a day coding or writing or researching on a screen, and your brain is going to look very, very different than someone who spends 10 hours just scrolling shorts.
It's the format.
The format itself is the drug. The medium is the message, and in this case, the medium is also the mechanism of addiction.
Okay, so let's break down that format. Let's talk about the mechanism of the trap. I was just thinking about the user interface while prepping for this. It's so deceptively simple, but every single pixel seems engineered for retention.
It is.
You've got the full screen immersion, the sound is on by default, the autoplay, the looping. But the one thing that really stood out to me in the behavioral analysis was the swipe. It's so low friction.
It's the elimination of what we call the stopping cue. Think about older media. A TV show ended, right?
Yeah.
You got credits, a commercial break.
A chapter in a book finished, you get to the end of the page.
The newspaper ran out of pages. Those were all natural, built-in stopping cues where your brain had a moment to reassess. Okay, do I want to continue? Do I want to start another episode?
And the endless scroll just removes that.
It removes it completely. The swipe is technically a choice, but the caloric cost of making that decision is effectively zero. It's a muscle memory flick of the thumb.
But that's just the interface. The real engine, the thing that keeps that thumb moving even when you want to stop, is what's happening chemically.
Right. This is where we have to talk about variable ratio reinforcement.
I remember this from, like, Psych 101. This is the B.F. Skinner box, right?
That's the one. The classic experiment. You have a rat in a box, there's a lever, and there's a food pellet dispenser.
Right. And if the rat presses the lever and gets a pellet every single time, it gets predictable. It eventually gets full or just bored.
Exactly. It's called fixed ratio reinforcement. And if it never gets a pellet, it gives up pretty quickly. But if it gets a pellet sometimes, unpredictably,
That's when it gets hooked. It'll just keep pressing that lever over and over.
it becomes obsessive. This is the fundamental architecture of a slot machine. It's the most powerful behavioral conditioning schedule known to psychology.
So when you open TikTok or Reels, you're essentially pulling the lever on a digital slot machine.
1,000 times an hour. Most of the content you see is, let's be honest, filler. It's a repost, a boring story, an ad you don't care about. That's the loss. That's the cherry lemon on the slot machine.
But then suddenly you hit a video that is it's perfectly tailored to your humor or your niche interest or your insecurity.
And that's the jackpot. Bells go off in your brain.
And because the videos are so incredibly short, 15, maybe 30 seconds, you're pulling that lever 3, 4, 5 times a minute.
And that speed is absolutely crucial. We're talking about something called phasic spikes of dopamine. In a casino, the slot machine takes a few seconds to skin. There's a delay.
There's some anticipation.
Right. In a short video app, the feedback loop is almost instantaneous. You swipe, you judge it, you get a hit or a miss, and you swipe again. The brain creates this prediction error model. It expects a reward.
So what happens when it doesn't get one?
When it doesn't get one, when the video is boring, dopamine levels actually dip slightly below baseline. This creates a tiny, almost imperceptible feeling of craving.
And when it does get one?
Dopamine spikes, creating pleasure and reinforcing the action. It's this rapid oscillation between craving and pleasure hundreds of times in a session that conditions the brain to seek the next spike immediately. It's incredibly potent.
It effectively short-circuits the entire reward system. It's like hot wiring it.
That's a great way to put it.
And the sources, they mention a specific term for the result of this conditioning, TikTok brain. Now, I honestly thought this was just a media buzzword, some catchy phrase for a news article.
A lot of people do.
But the researchers are using it in academic papers now. Seriously.
They are. I mean, they're using it to describe a specific neuropsychological phenotype. It's not a formal medical diagnosis in the DSM-5 yet, but it's a recognized and studied pattern.
Okay, so what defines this pattern? What is TikTok brain?
It's characterized by a cluster of traits. One is heightened impulsivity. Another is a distinct preference for high-novelty stimuli. And the big one is a significantly lowered tolerance for delayed gratification.
That last part, the low tolerance for delayed gratification, that feels like the core of it. That's the I can't sit through a movie anymore syndrome.
It is, or I can't read a book, or I can't listen to a full album. If you train your brain for hours every day, that entertainment comes in 15-second high-impact bursts with zero buildup.
Then a 2-hour movie with, character development and a slow first act.
It feels agonizingly slow. It feels like work. Your brain is literally screaming, where is the dopamine? Why hasn't the context shifted yet? Where's the next hit? You're fighting against your own neural conditioning.
This brings us right to the cognitive cost. Because we can't just live in the feed. We have to, function in the world. We have to work and study and have relationships. So I want to drill down into this attention span data. There's a lot of panic about this. You hear it all the time. But what does the data actually say? Are we really losing the ability to focus? Or are we just, choosing not to?
The evidence points pretty strongly to a functional degradation of attention. So it's not just a preference, it's becoming a capacity issue.
Okay.
We have multiple studies now showing a direct correlation. The heavier the use of short-form video, the worse the performance on standardized sustained attention tasks.
And what's the mechanism there? Why does watching short videos make you worse at long focused tasks?
A big driver of this is something called context switching.
I think everyone listening knows this feeling viscerally. You're scrolling and you see a video about, say, a humanitarian crisis in a war zone. It's heavy, it's tragic, it's emotional.
Right, you feel a pang of
You
something.
feel something, then you swipe. Boom, someone is dancing to a pop song. Swipe again, a 30-second recipe for sourdough bread. Swipe again, a clip from a stand-up special. Swipe again, a wild conspiracy theory.
Think about the cognitive load that is required to process that stream of information. In the real world, context shifts slowly. You leave a funeral and you drive to a party, you have travel time, you have a mental transition
You
period.
have time to decompress and reset.
Exactly. In the feed, you are forced to switch your entire emotional and intellectual context every 15 seconds. This creates what psychologists call attention residue.
Attention residue.
Part of your brain is still processing the tragedy from 3 videos ago,
Right.
while the front of your brain is trying to process the dance. The result is a profound shallowing of processing power. You can't engage deeply with any of it.
Because your working memory is just completely overwhelmed.
It's overwhelmed by the sheer volume of unrelated high-impact stimuli.
It's like trying to have 5 different conversations with 5 different people at the exact same time. You're not really listening to any of them.
That's a perfect analogy.
Yeah.
And this constant fragmentation prevents what we call deep engagement. The brain habituates. It gets used to processing information in these disconnected, atomized bursts,
So when you then try to sit down and say, read a textbook for a class.
which requires linear, cumulative, deep processing. Your brain struggles to hold the thread. It's looking for the next cut, the next transition, the next swipe.
The academic impact of this is, it's measurable and it's scary. I was looking at that one study of undergraduates in the source pile. It found that real consumption.
Yeah, this one was a shocker.
It accounted for 25% of the variance in academic performance. That is a staggering number.
It's a massive explanatory variable. 25%. Think about that.
A quarter of the difference between a student with a 4.0 GPA and a student with a 2.0 GPA could be statistically attributed to how much time they spent on Instagram Reels.
Right. And to be clear, it's not just about the time lost to procrastination, though that is a huge factor,
Sure, if you're scrolling instead of studying, you'll do worse.
of course. But what's more insidious is the impact on the quality of the study time. If you say you're going to study for an hour, but you check your phone every 10 minutes for a quick break,
You're not really studying for an hour.
you're studying for 6 10-minute blocks with a hard reset in between. You are never entering a state of deep concentration or what's called a flow state. You're constantly resetting your cognitive ramp-up over and over again.
Speaking of breaks, there was this incredibly counterintuitive finding about boredom in that same study. I had to read this section twice because it just didn't make sense to me at first.
The boredom proneness paradox, yeah. It's fascinating.
It looked at a personality trait called boredom proneness. Now, my assumption would be that people who get bored easily are the most addicted, right? Because they need that constant stream of new stimulation.
That's the logical assumption, absolutely. But the data said the opposite.
It was the opposite. Why? How does being a more boring person or getting bored easily save you from this?
Well, the hypothesis is that people with high boredom proneness, they get bored of the app too.
Oh.
They swipe for a bit, the dopamine hit isn't strong enough or novel enough, their threshold for stimulation is very high. So they get fidgety, they close the app, and they go do something else.
So their lack of a long attention span actually protects them from getting sucked in for hours?
In a weird way, yes. Their fidgetiness prevents them from getting locked into the trance. The people who are most at risk, paradoxically, might be those who actually have a high capacity to be deeply absorbed by things.
But that absorption capacity gets hijacked by the algorithm.
It gets hijacked. They enter that flow state, but it's what some researchers are calling a junk flow. They aren't bored, they are completely entranced for hours, but it's a passive, consumptive state.
That distinction between junk flow and real flow is so critical. Real flow is generative. You're building something, you're solving a problem, you're creating.
You're an active participant.
Junk flow is just passive consumption. You're just a vessel for content.
And that jump flow state actively disrupts your ability to achieve real flow later. Because real flow, like you said, requires pushing through an initial barrier of frustration or boredom. When you start writing an essay, the first 10 minutes are awful.
A blank page is terrifying. You want to quit.
You want to quit. And if you have a perfect dopamine dispenser in your pocket, you quit immediately. You check your phone. You never push through that initial barrier to get to the good part of deep thinking.
Okay, so we've established the behavior, the chemical loop, and the cognitive cost. But I want to get to the real meat of this deep dive. The structural changes to the brain. This is where the science goes from, concerning to, frankly, a little bit frightening.
This is the neuroanatomy, yeah.
You said earlier that the brain is remodeling itself. Let's walk through the specific regions that the studies are flagging. The first one on the list is the OFC, the orbitofrontal cortex.
Right. So the OFC is a chunk of the prefrontal cortex sitting right behind your eyes. It is basically mission control for reward valuation and decision-making.
So it's the part that helps you weigh pros and cons.
Exactly. Should I eat this donut? The pro is it's delicious. The con is the calories. Should I buy these shoes? Should I watch one more video before bed? That's your OFC at work.
And the studies are showing that in heavy SVA users, the gray matter volume in the OFC increases. It gets bigger.
It does.
Now, typically when I hear increased brain volume, my mind goes to that famous London taxi driver study. Where they found the drivers had larger hippocampi because they'd memorized the entire map of London.
Right, a classic neuroplasticity study.
And we usually frame that kind of growth as good. It's a skill.
Yeah.
So why is a bigger OFC bad news here?
Context is everything. In the taxi driver example, the growth was functional. It represented stored data, a map. In the case of short video addiction, the increased volume in the OFC is interpreted as structural hyperactivation or compensatory plasticity.
What does that mean in simple terms?
Think of it less like a muscle getting stronger from healthy exercise and more like a callus forming from constant repetitive friction. Or maybe a better analogy is a lymph node swelling up because of an infection.
So it's inflamed, it's overworked.
In a sense, yes. The OFC is being bombarded with thousands of micro-decisions per hour. Watch or swipe, like or scroll, comment or share. Is this rewarding or not? It is processing a volume and velocity of reward evaluation that it simply did not evolve to handle.
And the brain's response is to just build more of it to try and keep up.
It seems so. The increased volume likely represents an inefficiency. The brain is throwing more resources, more neural tissue at the problem to try and keep up with the dopamine flood. It suggests the entire system is under chronic, unsustainable load.
That makes so much more sense. It's swollen from overuse.
Okay, the second region that popped up in the MRI scans was the cerebellum.
All right.
And again, this one really surprised me because, high school biology taught me the cerebellum is for balance, motor control, catching a ball. Why is it lighting up and growing for a teenager who's lying perfectly still in bed watching TikToks?
That view of the cerebellum is about 30 years out of date. It's one of the biggest revisions in modern neuroscience. We now know the cerebellum is more like the master sequencer of the brain.
The sequence.
Yes, it sequences movement, but it also sequences thought and emotion. It's constantly predicting what comes next in any given pattern. Short-form video is a sensory fire hose.
It's incredibly dynamic, rapid cuts, flashing text on screen, music syncing with fast movements. The cerebellum has to work overtime to integrate all this sensory data and predict the rhythm of the content. It's trying to make sense of the chaos.
So the cerebellum is growing because it's essentially trying to learn the beat of the algorithm.
Precisely. It's adapting to the speed and the sensory richness of the input. But again, you have to ask, what's the trade-off? Optimizing your brain for processing 15-second visual rhythms doesn't necessarily help you write a long thesis or have a slow, nuanced face-to-face conversation with a partner.
So we have growth, or maybe swelling in, the reward evaluator, the OFC, and the sensory processor, the cerebellum. But then we have the flip side, which is atrophy, actual shrinkage.
Yes.
In the areas that matter most for self-control. This is the really scary part for me. The anterior cingulate cortex, the ACC.
The ACC is, for all intents and purposes, the brain's braking system.
Yeah.
It's deeply involved in inhibitory control, conflict monitoring, and error detection.
It's the part of your brain that says, hey, you have that big meeting tomorrow morning, maybe don't watch another one.
That's the voice of your ACC.
Yeah.
And the studies are consistently showing volume reductions, less gray matter in the ACC, and also the amygdala in users with high SVA symptoms.
Okay, let's use the car analogy here. If the OFC is the gas pedal, the drive for reward, and the ACC is the brake pedal.
then what we are seeing is a brain where the engine is being bored out to a massive horsepower, and at the same time, the brake lines are being systematically cut.
Wow.
You have a developing structural mismatch. The neural hardware driving you to consume is physically growing stronger, while the hardware required to stop that consumption is physically withering away.
This changes how we have to think about willpower, doesn't it? If I tell someone to just put the phone down, I'm asking them to use a muscle, the ACC, that has literally atrophied from disuse.
That's exactly right. It's not just a moral failing or lack of discipline, it's a physiological deficit. The neural pathway for inhibition is weaker. The electrical signal to stop literally can't compete with the stronger, bigger, more robust signal to go.
I want to zoom out for a second from the specific regions to how they all talk to each other. The research papers call this the triple network model. I'll be honest, when I first looked at the diagram, it just looked like a bowl of spaghetti.
It can look that way.
But the way you broke it down for me in the notes, the CEO, the daydreamer, and the manager, that really clicked. Can you walk the listener through that framework?
Sure. It's a great way to understand how focus works or doesn't work.
Yeah.
In your brain, you have three main large-scale networks that are often in competition.
Okay.
First, you have the default mode network, or DMN. This is the daydreamer. It's most active when you're zoning out, thinking about yourself, your past, your future, or just mind-wandering.
When you're staring out the window in a boring meeting.
That's your DMN taking over. Second, you have the central executive network, or CEN. This is the CEO. It's active when you are actively focusing on a task, solving a math problem, writing an email, or listening intently to this deep dive.
And you can't really have both fully active at the same time, right? You can't be daydreaming and doing calculus simultaneously.
Ideally, no. They are what we call anti-correlated. In a healthy brain, when one turns on, the other is suppressed and turns off.
So what's the switch?
The switch is the third network, the salience network, or SN. The salience network is the office manager. Its job is to monitor the world and your internal state for what's important, or salient. It notices something important. Hey, the boss just called your name, and it tells the daydreamer to be quiet and activates the CEO.
Okay, so CEO, daydreamer, and the manager who switches between them. So what happens to this whole office in a brain that's addicted to short-form video?
The manager stops doing its job effectively. In SVA subjects, we see a clear dysfunction in the salience network. Specifically, it fails to properly shut down the default mode network when the executive network needs to come online and work.
So the daydreamer is just wandering into the CEO's office in the middle of a big board meeting.
That's exactly what's happening neurologically. The DMN remains hyperactive, even during tasks that demand focus. This provides a biological explanation for the brain fog that people report after scrolling.
It's that feeling of trying to focus on your work.
But the daydreamer is still babbling in the background about that video you saw, or that comment someone left. The brain struggles to toggle out of that passive, self-referential state that the app encourages. You are physically present at your desk, but neurologically, you are still half scrolling.
That explains so much, that feeling of just staring at a Word document and you can't engage. Your brain won't lock on. It's because the neural switch is stuck.
It's stuck, or at least it's become very rusty. And the scary thing is, the more you stay in the app, which is a very passive DMN-heavy state, the rustier that switch becomes. You're practicing distraction.
Let's pivot from focus to decision-making. There was this one study using something called the mixed gambling task that I found really, really revealing about how this affects our judgment of risk.
The Iowa gambling task variant. Yeah, this is a classic test.
Because you'd think, oh, it's just watching videos, it's not real gambling, but the brain doesn't seem to know the difference.
This study used fMRI to actually watch people's brains as they made split-second decisions about risk and reward. They showed participants a card where they could win or lose a certain amount of money.
And what did they find in the high SVA users?
They found a significantly reduced sense of loss aversion.
Break that down for us. Loss aversion is normally a good thing, right? It's the gut feeling that keeps us safe. It's the, maybe I shouldn't bet the house on this one hand of poker.
It's a fundamental survival instinct. Daniel Kahneman won a Nobel Prize for this work. Evolutionarily, losing your food supply is a much bigger deal than finding some extra food is a good deal. So we are wired to feel the sting of a loss about twice as hard as we feel the joy of an equivalent gain.
It makes us cautious.
It makes us cautious. But the high SVA users, they were desensitized to loss. They didn't show the typical neural spike of fear or caution in their brain scans when they were faced with a potentially bad bet.
How does that map onto scrolling? The loss, there isn't money.
Think about the cost of a late-night scroll session. You are losing sleep. That's a loss. You're losing energy and focus for the next day. You're losing time with your family. Those are all real, tangible losses.
But if your brain has reduced loss aversion,
You underestimate those long-term costs. You don't feel the sting of a lost sleep until it's too late. You only focus on the potential immediate gain of the next funny video. The short-term pleasure outweighs the long-term pain.
the study also mentioned something called the drift diffusion model, which sounds like a physics term, but it's about the speed of decision making.
Right. It's a mathematical model of how we gather evidence to make a choice. Imagine you're deciding which sandwich to buy for lunch. You gather evidence, price, ingredients, freshness, what you had yesterday. Once you have enough evidence to cross a certain threshold, you decide.
And what did the model show for SVA users?
It showed that they have a much lower threshold for evidence accumulation. They decide faster, with less information. They don't wait to gather all the facts.
They're trigger happy.
They are clicking before they are thinking, and the fMRI scans back this up. During these hasty decisions, the precuneus, a brain area involved in calculation, self-reflection, and weighing evidence, was unusually quiet.
So the thinking part of the brain was offline.
It was being bypassed.
Yeah.
But the motor areas, the parts of the brain that control moving the thumb to make a choice, were lighting up very quickly. They were going straight from stimulus to the doing brain and skipping the thinking brain in the middle.
It's a recipe for impulsive living. And I just have to wonder how that bleeds out into the rest of life. If you train yourself to make decisions that fast on a screen, do you start making them that fast in a relationship? Or with your finances?
That's the billion-dollar question, isn't it? The deep concern is that these neural patterns don't stay in the pocket. If you train your brain's fundamental operating system to be impulsive and risk-blind for 4 hours a day, that becomes your default mode for operating in the world.
I want to touch on the psychological drivers here for a minute. We've talked a lot about the hardware, the neuroanatomy, but what about the software, the emotions? There was a very specific and powerful link in the research between SVA and dispositional envy.
This is a really key point. It's what separates, say, a TikTok addiction from a World of Warcraft addiction. It's the social comparison element.
So what is dispositional envy?
It's a stable personality trait. It describes a person's general tendency to feel distress, frustration, or inadequacy when they see others succeeding or having things they don't. And the data shows a very strong correlation. The more envious you are by nature, the more likely you are to get hooked on short-form video.
It's such a cruel loop, isn't it? The algorithm's job is to feed you the most engaging content, which often means the most curated, aspirational content. The best lives of other people.
Beautiful vacations, perfect bodies, expensive houses, happy relationships.
And if you are a person who is already prone to envy, seeing that constant stream of perfection triggers a painful feeling of inadequacy.
Right. And here's the core of the paradox. To cope with that bad feeling, that feeling of inadequacy, the user turns back to the app for distraction and numbness.
They use the app to numb the pain that is being caused by the app?
It becomes a profoundly dysfunctional coping mechanism. The research showed that the neural scans could actually see this happening.
In the temporal pole, right?
Yes, the temporal pole is a region that helps process social and emotional concepts and helps us understand others' mental states. And they saw specific changes in that area that mediated this envy addiction link. It suggests that for a large subset of users, the addiction isn't really about entertainment. It's about mood modification.
They're self-medicating their social anxiety with tiny hits of dopamine.
That's a very good way to put it.
We absolutely need to talk about who is most at risk here. The research flags two major demographics, or maybe biological contexts. The first, and maybe the most important, is adolescence. We have listeners with kids or who are young themselves. Why is the teenage brain what you called a perfect victim for this kind of algorithm?
It all comes down to the mismatch theory of brain development. The brain doesn't mature all at once evenly. It matures in waves, generally from the back to the front.
Okay.
In adolescence, the subcortical reward regions, the limbic system, the amygdala, the nucleus accumbens, these are fully developed. They are running hot. This is the gas pedal of the brain.
So teenagers feel emotion and the drive for reward very, very intensely.
More intensely than at any other point in life.
Okay.
But the frontal cortex, the part right behind the forehead that's responsible for judgment, impulse control, and long-term planning, That's the brakes.
And that part is still under construction.
It's totally under construction.
Oh.
The prefrontal cortex doesn't finish myelinating or wiring itself up until your mid-20s. So what you have biologically is a Ferrari engine inside a car with bicycle brakes.
And then society hands that driver a device that is specifically designed to just slam the gas pedal to the floor over and over.
That's the mismatch. And it's not just a behavioral issue, it's a structural risk.
Yeah.
One of the papers mentioned transcriptomic analysis. This is cutting-edge genetic research.
What did it find?
It looked at when certain genes are expressed or turned on in the brain across a lifespan. It found that the specific genes associated with the brain changes we see in addiction are predominantly and most powerfully expressed during adolescence.
So the brain is genetically open for business during those years. It's just waiting for instructions from the environment on how to wire itself for adulthood.
It is. It's a critical window. It's undergoing a process called synaptic pruning. The brain is literally cutting away unused connections to become more efficient.
So if a teenager spends 6 hours a day scrolling,
The brain gets the message. It says, okay, this is what we do now. We need to be really, really good at rapid visual processing and impulsive swiping. We clearly don't need these long, slow, deep pathways for reading a novel or for sustained focus. It might prune away the very infrastructure they're going to need for the demands of adulthood.
that is a terrifying thought. That we are potentially hardwiring a generation for impulsivity. The study used the phrase arresting their maturation.
It's a real and serious possibility. We might be creating a kind of Peter Pan brain structure, one that struggles to transition to the executive demands of adult life because the foundational wiring was optimized for a completely different world.
The other major demographic split in the research was along gender lines. The studies found different patterns of vulnerability for males and females. Now, obviously, these are broad statistical trends, not rules for every single individual.
Of course, averages, not destinies.
But the differences were quite stark.
They were. For females, the vulnerability seems to be rooted more in the affective or social network of the brain. The addiction is often driven by things like emotional communication, social maintenance, and that strong envy component we just discussed.
And the neural signatures reflected that.
They did. The changes were more prominent in the insula and the amygdala regions that are deeply linked to emotion, social awareness, and interoception, which is the sense of your own internal state.
So for women, the hook might be more about the anxiety of connection. The what are people doing? What am I missing out on? How do I compare?
It seems to be more socially and emotionally loaded on average. For males, the vulnerability tended to map more onto the executive and impulse control network. Their usage was often driven more by things like sensation-seeking, gaming-like mechanics, novelty, and humor. And the neural signatures showed up as things like impaired white matter integrity in the control circuits. So faulty wiring for the brakes.
So to oversimplify, for men, it might present more as a raw impulse control failure. I just want to see the next cool thing.
Right.
And for women, it might be more of an emotional regulation failure. I feel anxious or inadequate, and I need to soothe that feeling.
That's a very good summary of the trend in the data. And this really matters because it means the solution isn't one size fits all. A simple digital detox might work for the guy who just needs to break the habit loop.
But for the girl whose scrolling is driven by a deep-seated social envy,
Taking her phone away doesn't solve the underlying self-esteem issue or the intense need for connection. She might need a completely different kind of intervention that addresses the root cause.
before we wrap up, we have to talk about the physical anchor of all of this, which is sleep. Everyone scrolls in bed. I do it. You probably do it. But the research suggests this is specifically the most damaging time to engage with short-form content.
It is the absolute worst time. We've all heard about the blue light from screens suppressing melatonin. That's old science at this point. That's true, but it's not the main problem.
What's the main problem?
It's arousal. When you watch a fast-paced, emotionally volatile stream of TikToks, you are spiking your cortisol and your dopamine. You are keeping your brain's arousal systems in a state of high alert.
You're trying to go to sleep, but you're telling your brain that it's time to be vigilant and excited. You're revving the engine right before you need to park the car for the night.
Exactly. And this creates a vicious cycle. You scroll, which means you get less sleep, and the sleep you do get is lower quality because your arousal systems are overactive and prevent you from getting into deep sleep.
And then what happens the next day?
Sleep deprivation's number one victim is the prefrontal cortex, the brakes. So the next day, your willpower and your impulse control are physically measurably lower.
Which makes you more likely to get sucked into scrolling.
Which ruins your sleep again. It is
Yeah.
a self-reinforcing downward spiral where poor sleep degrades impulse control, which leads to more scrolling, which leads to poorer sleep.
So we've painted a pretty grim picture here. We've got structural inflammation in the reward centers, we've got atrophy in the control centers, functional breakage in the attention networks, and a sleep deprivation feedback loop.
Mm-hmm.
The big question, one I think everyone listening is asking themselves right now is this permanent brain damage? Or is this just adaptation?
This is the philosophical and biological crux of the whole issue.
Yeah.
And the honest answer is, technically, it is adaptation. Neuroplasticity, the brain's ability to change, is neutral.
The brain doesn't know what's good or bad.
It only knows what is frequent. It observes your behavior and says, I see. I live in a world of 15-second clips now, so I will reconfigure myself to process 15-second clips as efficiently as possible.
It's doing a great job at the task we're giving it.
It's doing a perfect job. The brain is successfully adapting to the environment it's placed in. The problem is that the environment, the app, is profoundly maladaptive for the goals of a healthy, productive, and connected human life,
We are optimizing our brains for a digital simulation.
at the direct expense of our capability and presence in the physical world.
Can we reverse it? If I throw my phone in the ocean today, does my ACC grow back? Does my attention span come back?
The good news is that neuroplasticity cuts both ways. The research we have on digital detox is very promising. Recovery happens.
How quickly?
Some things are fast. Sleep quality can bounce back within days as those arousal levels drop. Attention and executive function take longer weeks or even months because you have to physically rebuild and strengthen those neural pathways for sustained focus. You have to, in essence, go to the gym for your attention span.
You have to retrain the brain to be bored again.
You have to reclaim boredom. Boredom is not the enemy. Boredom is the physiological signal that the default mode network is ready to do its real, generative job, internal problem solving, creativity, future planning, rather than just being passively hijacked by an algorithm running on a server in a data center.
That's a really powerful reframing. We treat boredom like a defect, a problem to be solved immediately with our phones, but it's actually a necessary state for deep thought.
It's the soil from which creativity grows. If you never let your mind wander on its own terms, you never really find out where it wants to go, you only ever let it go where the algorithm directs it.
So, to recap the mission of this deep dive, we aren't just wasting time when we scroll. We are actively remodeling our brain's physical structure. We are growing our reward centers, shrinking our control centers, and dulling our ability to feel long-term consequences.
And for the younger generation, we risk locking these changes in during the most critical window of brain development, with consequences we can't yet fully predict.
I want to leave our listener with a final, slightly provocative thought to chew on. We've talked about adaptation. If our brains are physically growing new infrastructure, literal gray matter to handle short-form algorithms, are we, in a way, evolving to become incompatible with the slow world of reality? If we continue down this path, what does the cognitive landscape of the next generation look like? Will they be physically unable to read a book or sit through a sunset or have a difficult conversation without a phasic dopamine spike every 15 seconds? And if so, what happens to the big, slow, difficult problems that our world needs deep thinking to solve?
It's a question we need to answer before the adaptation becomes the new permanent baseline. We are running a massive, uncontrolled experiment on the human mind, and the early results are in.
I'm going to challenge you. Don't scroll immediately after this. Just for a minute. Put the phone down, maybe go for a walk. Let your brain be bored for 5 minutes. Just see what happens. See you next time.